Hey, it's Mr. Ashi with Geometry 1.4 notes. We'll be talking a little bit later about perimeter and area of polygons in a coordinate plane. So a polygon, we talked a little bit about polygons, I think, when we were doing our little scavenger hunt. It's basically a shape. The other day we were talking specifically about plane or Euclidean geometry. A polygon is a figure in a plane made up of at least three sides, and it's an enclosed figure in a plane made up of at least three sides. You can't have a polygon with just one side. Then it would be a segment. If you had a polygon with two sides, that would be just an angle. Okay, but you need to be familiar with the names of specific polygons. So if a polygon specifically has three sides, I can draw an example, but I think everybody knows what a polygon with three sides is. It's a triangle. Polygon with four sides. Yes, a square is a polygon with four sides. Yes, a rectangle is a polygon with four sides. Those are more specific names. Every polygon with four sides is a quadrilateral. So really, we're taking a look at prefixes here. Tri meaning three, quad meaning four. A polygon with five sides is a pentagon, like the Pentagon in Arlington, Virginia. A polygon with six sides is a hexagon. A polygon with seven sides, either a heptagon or it could also be referred to as a septagon. A polygon with eight sides is an octagon. 9 sides, nonagon. And then 10 sides is decagon. If a polygon has an unknown number of sides, n, then it's just referred to as an n-gon. And I should have mentioned earlier as well, a polygon is an enclosed figure with at least three whole number sides. You can't have a polygon with like 3.5 sides. That's impossible. After that, there's a couple others with more specific names. If a polygon has like 15 sides, you just refer to it as a 15-gon. 27 sides, 27-gon, etc. So if I just draw a specific polygon, for example, a pentagon. Pentagon has 5 sides. So I could label the intersection of the sides or the segments like A, B, C, D, and E. This polygon is in a plane. It's in a flat surface. It has sides. The sides are the segments of the polygon. So a side's always going to be a segment. You name a side, just like you name a segment. So a side in that polygon that I just drew is side AB, side BC, and so on. So a side is just a segment in a polygon, and the segment has endpoints. Where two sides intersect or meet, for example, side AB intersects or meets side AE at point A. Okay, each of the points of intersection of two of the sides of the polygon are the vertices. So that's plural. Singular is vertex. So a vertex is just a point of intersection of two sides of a polygon. And it's just two sides. You can't have more than two sides of a polygon intersect. However many sides a polygon has, it would have that many vertices. Right? For example, a nonagon, 9 sides, it would have 9 vertices as well. It would actually also have 9 angles. We'll talk more about angles of a polygon later on in class. Polygons could either be convex or concave. I'm just going to go over like a general definition. You could look at a more formal definition of convex and concave polygons. We'll be sticking mostly with convex polygons when we're trying to figure out side lengths, angle measures of polygons, and so on. So maybe some of you are familiar with a geoboard. So if I had a geoboard, I would have like pegs at each of the vertices, and then I could put rubber bands for each of the sides of the polygon. And then if I took my finger and then placed it on, say, the middle of side AE, and then kind of pointed it in, here's what would happen with side AE. First of all, it would change the pentagon to a hexagon because one side would actually become 2. But everybody knows what a cave is. So the way that I try to describe it in simplest terms is a concave polygon looks like it's been dented in, or like it has a cave. You could fit something in there. So that's the difference between a convex. We started off with a convex pentagon. I didn't have any like caves or dented insides, but a concave polygon, it wouldn't be, once I like dented in this side right here, it wouldn't be a pentagon anymore. It'd be concave, but it'd be a concave, in this case, hexagon. So those are the basics of polygons.